Hello from ChemHelp ASAP. In this video we're going to do some simple formal charge sample calculations. So let's just jump right into it. On the screen we have some really nice Lewis dot structures, and maybe the backstory to this video is your friend has drawn a bunch of Lewis dot structures very nicely, but your friend doesn't know how to calculate formal charge. So we need to make sure that your friend has the correct formal charges on their Lewis dot structures. Now, if you remember, our formula for formal charge is shown on the top of the slide. So formal charge, or FC, equals the number of valence electrons in the atom, and that's we can simply find that through the group number. And then we subtract the number of electrons in the lone pairs, and then half the number of electrons in the bonds, the covalent bonds. And so this is sort of, when I think of this formula, this is what the atom should have, the number of valence electrons. And these two items are really what the atom does have. And by taking the difference, we find out whether the atom has a formal charge or not. So, first example, here is carbon. Carbon is our atom. And just filling in our column of information. How many electrons should carbon have based on its original valence electrons as an atom? It's group 4, should be 4, or 14, take off the tens place, that'll give us 4. The number of lone pairs, there are 0 lone pairs, therefore 0 electrons in those lone pairs. And it has 4 bonds. Remember, each bond 1, 2, 3, 4. And each bond has 2 electrons. 1/2 of 8 electrons is 4. So 4 minus 0 minus 4 gives us a formal charge of 0. So that carbon doesn't need a formal charge. Next atom is nitrogen. Nitrogen is in group 5. This nitrogen has 0 lone pairs, so there are no electrons there. This nitrogen has 4 bonds. 4 bonds have 2 electrons apiece, so that's 8 electrons. 1/2 in the upper right, 1/2 of 8 is 4. So 5, take away 0, take away 4, gives us plus 1. So this atom has a plus 1. We're going to write that on the atom and then circle that charge to make clear that that's a charge. It's not a stray mark or something we forgot to erase. Okay, the next molecule, we have chlorine. Chlorine has a number of valence electrons 7. It's in group 7 or 17. Take off the tens place. It has 3 lone pairs, and so 3 lone pairs have 6 total electrons, so that's 6. And this chlorine has 1 bond. That 1 bond has 2 electrons. 1/2 of 2 is 1, so 7. Take away 6, take away 1 is 0. And that chlorine has no formal charge, so we don't have to label it plus or minus. Now, this last one has 2 atoms. The first is the oxygen. Oxygen has 6 electrons in its valence shell. It's group 6. It has 3 lone pairs. That's 6 total electrons. So minus 6. And oxygen has 1 bond. And 1 bond has 2 electrons. 1/2 of 2 is 1. So we subtract the 1. And what we get is 6. Take away 6. Take away 1 gives us a minus 1. So let's take this oxygen, give it a minus, and make sure we circle that charge. And then we have carbon as our last atom. Carbon has, we already know, it has a valence of 4. It has no lone pairs, and it has 4 bonds with 8 electrons. 1/2 of 8 is 4. So 4, take away 0, take away 4 gives us 0. No formal charge on that carbon. So as you can see, once you get into a rhythm, this formula is very easy to apply, and it's very clear what you need to do. But this is a valuable service, and we helped your friend greatly by being able to assign formal charges to these structures.